Good afternoon, everyone. I'm Christiaan. I am part of the security and identity teams here at Google. And today I'm going to talk a little bit about FIDO authentication use cases. We're going to do a bit of a deep dive, and there is going to be a fairly technical component to this. Although we don't really have time to go into everything in excruciating detail. So although I will flash through some code samples and other things as we're going through here, the idea is that you can pause and kind of, go through those at your own leisure. I'm not going to go, code by code level, but I do want to kind of set expectations here that this session will be focusing on kind of the deeper side of current FIDO authentication use cases. Why don't we just start by, kind of setting stage here a little bit. Like, why is all this stuff important? I've shown this slide before. I think if you've seen any presentation that I've done, typically we start off showing this kind of phishing slide here and saying that phishing is actually on the rise and malware has been dropping since 2016, really. And we think the main reason for that is because phishing has become such low-hanging fruit, right? Phishing is a giant problem, probably the number one problem if you think about authentication on the web these days. But this slide has kind of dated, right? It goes to 2018, and I wanted to just take a look the other day and see where we are today, looking at the Google Safe Browsing Transparency Report here. So what's really interesting is, and this graph goes all the way to actually through October 2020, and we just see the last part there on the x-axis. We'll see that phishing is actually still a rather significant problem on the web today, as relating to malware here. And what's actually interesting is that most probably and most likely because of the whole COVID situation, we've actually seen a giant spike here in February of kind of just phishing sites and everything in general. And I think personally, this must have something to do with COVID and the fact that everyone is kind of sitting at home nowadays, and phishing just is a issue, right? If we look at what's happening in the news and what happened over the last couple of months here, phishing really still is a threat, and we should be doing everything that we can to try and address that. And luckily, FIDO is uniquely positioned to take on that challenge. So the rest of this presentation will focus a little bit on our view, I think, like the Google view, and then also, I guess, the FIDO view on authentication and how to deploy the various different use cases that FIDO has to offer. And the reason why I put this together really is because we believe that there is a gap between the specification and actually being able to implement WebAuthn and FIDO in the same way today. Specification is written kind of depending on your vantage point, like for web browsers and for physical security key and FIDO authenticator vendors. But from an RP perspective, there is a bit of a gap in some cases here, being able to, I guess, correctly deploy and synthesize the specification into real user journeys and use cases from an RP perspective. And we noticed that firsthand as a rather large relying party at Google. And that's why we kind of spearheaded the development of this how to FIDO document. And the link is down here in the last section here on the slide. So if you're interested in this in more detail, please feel free to refer to that. But I'm going to give you a rough overview here in the next couple of minutes on what we're trying to do with this particular document, and also just kind of going over the use cases and our way of thinking here. So first and foremost, let's talk a little bit more about authenticators. So in FIDO, an authenticator is the thing that does the work, right? That's the thing that holds the key material. That's the thing that does the cryptographic, not cryptocurrency, kind of cryptographic assertions and the work essentially to prove that it's the user that is, trying to exercise their particular credential. And with FIDO, we have loads of different types of authenticators. I've tried to, kind of divide them here into 4 different categories. Platform and roaming kind of at the top, and then user verifying and not user verifying along the y-axis there. And essentially, if we start at the lower or at the upper left-hand there, let's look at kind of, the user verifying platform authenticator firstly. So a user verifying platform authenticator is typically what we've all been used to since the launch of the iPhone 5S, right? It is a biometric or other type of user verifying sensor or mechanism that's built directly into a device. So typically, it's not something that's removable. It's built into the device. fingerprint sensor on the iPhone, same with Android, Windows Hello on Windows. That's an example of a platform user verifying authenticator. And this particular authenticator is very useful for re-authentication, right? Users that's coming back to a particular web property or coming back to a particular app after you've already verified them once in the past. We'll talk a little bit more about that in detail, but this is kind of just a bit of a level set. Then the other one that I want to talk about is the not user verifying roaming authenticator. So that's at the lower right-hand side of the quadrant here. And particularly what we're talking about there is these physical security keys that we've been talking about for years here at FIDO. We've deployed them at Google. We have the option for our users today to register these physical security keys to their Google accounts. And these physical security keys are really useful for offering a phishing-resistant second factor for account access. It's really kind of a single-step account bootstrapping, upping the security from kind of low security to higher security, where the user signs in, types username, type password, and then present a second factor. That's a workflow we're all very familiar with. But in this case, they present their security key. Why? Because the security key is strongly phishing resistant. So on the upper left-hand side is what we're all used to in terms of what's built into our phones and our platforms today. And on the lower right-hand side is the use case, probably the oldest one that we've seen around here, which is the physical second factor use case using a physical security key device. And then we have kind of two quadrants here that we haven't really talked a lot about also in the past at FIDO. The lower, I guess, left-hand one is the little smaller type security key that fits directly into a device that can't identify the user. So it's not user identifying, it's just anyone who taps it is able to exercise it. And typically for that particular device, we think the use case there is more to do with a defense in depth malware use case. Not going to go into that too much today. We don't have a lot of time for that. But if you read through the How to FIDO document, there is a specific section calling that out. That's also more of an enterprise use case, kind of an internal enterprise use case that we also have deployed at Google. The one that's a little bit more interesting, I think, is the one on the upper right-hand side, which is the phishing-resistant second factor, but also offering a phishing-resistant single-step account bootstrapping. So how does this work? We'll get into that in more detail, but essentially, instead of the user having to enter a username, a password, and then exercise their security key, with these types of devices, the user simply comes to a web property, they want to sign in, they take out their security key, plug it in, or present it, and at that point, verify their identity locally to the authenticator. So touching their fingerprint or typing a PIN code, at that point, getting a list of all the accounts that's on this particular key, and then magically being able to log in. So that's kind of the more, I guess, like forward experience that we're thinking about when we're talking about FIDO and passwordless, because here we can truly come to a brand new website that we've never logged into before on this particular machine, take out our security key, not having to type anything, just touch a fingerprint, and then magically being signed in. So kind of all of these different use cases will be discussed at some level of detail as we go through the deck here. So some high-level observations before we start. Long gone are the days, I think at least, of shared, library-type computers for most users. Users typically have machines that they interact with on a daily basis. Maybe it's a family computer, so it's shared by a couple of users in some trust environment, or maybe it's a personal device. And unless you as a relying party have a very good reason not to have your user session lost for a long time, please consider doing that purely from a user experience point of view. If you think about Google today, if you log into Gmail from a device, Gmail will likely not log you out on that device ever again, unless you take explicit action as a consumer. That is an experience that makes a little bit more sense for us, and especially as we're kind of thinking about the different FIDO use cases, we think that's a good starting point for most type of services. If you have to log a user out for some reason, maybe compliance, regulatory, financial services, perhaps healthcare, then at least remember that they have used multi-factor authentication on that particular machine before. In other words, if a user logs in to a service on a device and they type their username and their password and they exercise their second factor, probably not necessary to make them exercise that second factor again when they come back on that same machine. Like maybe you still want them to enter their password because you want to be sure it's the correct user in front of the device and maybe not a family member, but it's really there's no need to exercise a second multi-factor prompt here again. And from a convenience perspective, we really think that that is kind of balancing the convenience versus security argument here for us a little bit better. So those are kind of like, I guess, just some level setting arguments. If we think about this, like the password proves it's the right user in front of the machine, and then the second factor proves possession, right? It proves that the user has access to something, but that can be transferred to the machine that they're on. So yes, I maybe had to use my security key the first time I logged on, but then when I come back to this particular machine, I've kind of already proved that I trust this machine. So that trust can be transferred onto the device itself, and you don't have to go and pull out that second factor again. Another thing that I'll just mention before we go further, and we'll talk about this in more detail, account bootstrapping for us, which I also referenced earlier. Account bootstrapping applies when the relying party has no idea who's controlling the client device, right? This means that it's kind of first time logging into a web property on a machine. There is no cookie, no other credential, nothing available to the relying party to hint at who is going to be logging in on this device. So the idea here is that first the user has to be identified, and that can be done through the user perhaps entering an identifier string or perhaps reading something from a security key, and then from there on you would be serving the user some challenges as they go through the process. So just want to get that terminology in folks' minds here as we go through the deck. And now we're really starting into the meat of the deck here. Like the first use case I want to talk about a little bit is the traditional reauthentication use case. So this is distinct from the bootstrapping case that we just looked at, or the specific user journey. Here, essentially, a user has successfully logged into a platform before, maybe logging into a banking website or a banking app, whatever the case might be. A day later, they come back to this application, and now instead of making them type in their username and their password again, all we need to do is issue or at least query the local platform authenticator and try and figure out if this user is kind of the same person that originally registered on this particular device. So the idea would be that a user comes to a specific website, they sign in, username and password. The relying party, the website, would be issuing the ease user verifying platform authenticator call, double checking that this platform is FIDO capable. And if it is, then offer the user some kind of an opt-in, telling them that, hey, next time you come back to this website, you don't need to type all that stuff again. You can just touch your fingerprint. Once the user does that, next time that they come back to this particular website, as simple as the user just opening up that particular website and touching their fingerprint on a sensor and then magically being logged in. And the two calls we're talking about here, and we'll talk more about, is the ease UVPAA call. Is there a user verifying platform authenticator, and also the create call for making credentials on this particular platform. Again, as I said, not going to go through this in too much detail, but here is the pseudocode for this particular call if you're interested in calling this out. And then once the user comes back, it's very simple. At this point, instead of issuing a create call, you would just issue a get call. And you'd figure out, hey, is this the same user and the same device that the user was on earlier? And you can use the FIDO get call to try and get that assertion back and figure out if it's the right user on this particular platform. And that's what we're doing here. A user that previously registered on this particular device comes back to the device. We double check if it's the same user by issuing the FIDO credentials get call. If it's the same user, if they touch their fingerprint, a credential gets unlocked, and at that point, they're allowed into the particular web service without having to resort to any kind of password. So this is a very simple use case available today that relying parties could all use. It's available across many different platforms: Android, Windows, Mac, iOS. So definitely something for relying parties to look at implementing today. And here's, again, simple pseudocode for actually exercising this particular call. The other one that I want to talk about a little later, if you or at this point, if you think back to the deck that the slide that I showed earlier in the deck, the lower right hand, the second factor approach, right? This is where a user today signs in, username, password, and then goes and grabs their security key, probably the oldest FIDO use case that we have available. How does that work? Well, again, very, very simply, you issue the same type of FIDO call. You do a navigator credentials create call. But here you specify in particular that you want to talk to an external authenticator and not a platform authenticator. If you look here, cross-platform, very, very important. I'm going to go back a couple of slides here briefly just to show this. earlier on, when we did the create call here for the FIDO-based reauthentication, we specifically specified platform here as the attachment parameter, meaning this is for the reauthentication use case. Going again back to our phishing-resistant second factor use case, here we're explicitly saying I want an external authenticator that can be detached from the platform. It doesn't make sense to register a platform authenticator for a bootstrapping use case, because if the user comes back on a new device, they would by definition not have access to that authenticator. So very, very important to get your authenticator attachment right when calling these FIDO APIs or the WebAuthn APIs directly. So essentially, this is the type of browser UI that the user would see when you're trying to register one of these keys. And then later, when the user comes back, very, very simply, you issue a GET call again, and you pass in all of the particular credential IDs that you have for this user. And we'll see here in a couple of slides ago, I have a whole bunch of different authenticators registered. This is a sample from how it looks on Google accounts for these particular second factor use cases. And essentially, all of these keys have credential IDs associated with them, and all of those credential IDs would be passed in at the point in time when I'm making this particular call in order to identify that the user has one of these keys available during the account bootstrapping. So that's this particular use case. The last one I want to talk about really briefly is if we think back to the quadrant, is the one in the upper right-hand side, which looks very similar to the previous use case. But instead of using this as a way to kind of bolster the account security while keeping the UX roughly the same, so in other words, having the user enter a username and then a password and then exercising their security key, the user verifying roaming authenticators has the potential to cut out a lot of those steps. So the user experience here would be a user comes to a website, they simply grab their key, put it into the machine, touch their fingerprint, and be magically signed in, right? That's kind of the experience we're going for here. So the true passwordless, even usernameless flow in some cases is possible and made possible by these user verifying roaming authenticators. This really is the set up your account without even bothering with passwords type approach. And again, this is also a use case that's possible today and is implemented on a lot of the major browsers right now. So if you think about how this works, well, again, you do the same thing. You do a navigator.credentials.create call. Again, take care to specify cross-platform. It means you don't want a platform authenticator. You want a physical, actual removable security key, essentially, for registration. But when you register it this time, you actually say that you need the key to be able to remember the username for the user or the user ID, and you need user verification. In other words, you need the key to be able to verify the user. Because we're going to get rid of the password, we need to put that trust somewhere else. So essentially, we're telling the security key here, or the authenticator, that it will need to identify the user before unlocking key material, which is why we're using the user verification required property here. And then the last thing I'll just quickly mention here is, like, how do you choose as a relying party whether you want to implement the use case which is second factor purely only, or the UVRA, like user verifying roaming authenticator first factor use case, where you can get rid of usernames and passwords. And from our perspective, we're kind of thinking that although both of these offer similar security, it does differ a little bit in terms of user experience, right? In the one, the user still has a username and password, and the other one, they don't. So we're kind of thinking right now that leaving it up to whatever equipment or technology the user has is a good idea. And we have a change coming in the WebAuthn Level 2 specification, as we call out here, where the relying party can basically say, hey, give me any of these two use cases. It really just depends on what hardware the user has in their hands. So if they have an old type security key that can't do UVRA, you'll just use it as a second factor. If they have a newer type device that can do UVRA, great, we'll create a key pair, and then in the future we can use it as a as an authenticator where the user doesn't even have to remember usernames and passwords. They can simply authenticate directly to the particular key. And we can kind of go through this in more detail, but the idea essentially is that if you do that from a code sample perspective, essentially what you're saying is give me a cross-platform key. Prefer resident keys and prefer user verification. Remember, when we looked at this earlier, we said resident key is true and user verification is true. Here we're saying, or required at least, here we're saying preferred is good enough. Like, we prefer that the key can actually act as a replacement to a username and a password, but if it can't, if it's old, don't fail. Give us back the best thing that you can, and then we'll just use it on our side as either a first factor or a second factor, depending on the hardware that the user owns. And here again, the get call is probably the easiest one here for this use case. You don't have to pass in anything, like no credential IDs, nothing else. You just pass in your challenge in the RPID, and you say, hey, I want to verify the user. And at that point in time, the user is just required to put in their security key into the port, touch it by authenticating to it with a fingerprint or typing in a PIN code, and at that point, authenticating to the particular website in question. I know I went over this very, very briefly, but the idea here is to give you an idea of what's possible today, which things you don't have to wait for. Pretty much everything I spoke about here today is available in most web browsers. So really, the time to implement is now. If you're interested in playing with some of these use cases, the howtofido.securitypoc.com is a great demo website from IBM. We have a server up and running there. There's more details around the code lab there in bullet point number 3 that we've done. And then lastly, number 4 has all of the details that I discussed here today, but in much, much, much more, I guess, depth, where you can go through and even get code samples on how to implement all these various things. So with that, thank you very much, and time for Q&A.